Alright, so 50.9 has 3 sig figs because 5 is a significant figure and so is 9, and because the 0 is in between them, it also makes it a sig fig. Alright, so for number 2, 5009 has 4 sig figs because 5 and 9 are sig figs again, and the zeros are sandwiched in, so it has a total of 4 sig figs. And then for number 3, it has 2 sig figs because the 2 and the 8 are after all the zeros, and the zeros are not sandwiched in by any other sig figs. For number 4, there are 4 sig figs because the 9 and the 5 come first, and they are both sig figs, so any zeros after the decimal are also significant figures. And last, for number 5, there are 3 significant figures because the 6 and 5 are sig figs, and they are sandwiching in one of the zeros, but the last 0 is not sandwiched in, so it only has 3 sig figs. Alright, so for number 6, there are 3 sig figs because the first part of the question right here has 3 sig figs, and you choose the amount of sig figs for whichever one has more. And yeah, so for number 7, there are all 6 sig figs because the second part, which you're subtracting, has 6 significant figures, and therefore you round to all 6 sig figures. Alright, so for number 8, there are only 2 sig figs because in both of the questions there are only 2, and therefore you only round to 2 sig figs. And then for number 9, you round to 2 sig figs because in this part there are only 2, while in this part there are 4, but it's multiplying and dividing, so you just do whichever has the least. Alright, so for number 1, it is silver chloride because it is just a basic compound and you add "ide" to the end of it. And same thing for number 2, so it's zinc oxide. And same for number 3, so it's calcium bromide. Alright, so for number 4, it is special because once you cross it and make it tin 4 fluoride, you notice that there are 4 fluorine. So each of them have a -1 charge, so that the tin has a +4 charge overall, which is why you give it the 4 in the middle. Then for number 5, it is barium nitrate because it is already a polyatomic, and you just leave the name. Okay, so for number 6, it's copper chloride because there are 2 chlorine atoms, and those are both -1 charges, and then when you cross it over, it means that copper has +2 charge, given the 2 over here. Alright, so for number 7, it is simply just potassium nitride because there are 2 normal atoms and then they make a normal compound. And same thing for number 8, it's just cadmium oxide. And alright, so the last one is aluminum bromide because it is just 2 atoms and it makes a normal compound.
Okay, so potassium iodide is just going to be Ki because potassium is has a +1 charge, and iodine is a -1 charge, and when they cross over, it's just K1 and I1. You don't have to write those. And then basically the same thing for the rest of them. Like magnesium chloride will have a +2 charge, and chlorine will have a -1 charge. So when they cross, it gives the chlorine the subscript of 2. And basically just go through that for every single one. You get Na2S for sodium sulfide, CuCl2 for copper 2 chloride, SnF2 for tin 2 fluoride, Ca3N2 for calcium nitride, CS2SO4 for cesium sulfate, Na3PO4 for sodium phosphate, Na2SO3 for sodium sulfite, and AlCl3 for aluminum chloride. Okay, so since these are all just covalent compounds, you just use the subscript to name them, like since it's S2, it's going to be disulfur, and O3 is going to be trioxide. So that's that right there. And then it's basically the same thing for all of them. So it'll be iodine trichloride, phosphorus pentabromide because there's 5, phosphorus pentafluoride, xenon tetrafluoride, and carbon tetrachloride.
So the answer for number 1 is O2F2 because dioxygen and difluoride have the prefix di in front of it, and that means 2. For number 2, carbon tetraiodide is Ci4, and you get the 4 from the tetra, which is the prefix for iodide, and carbon doesn't have a prefix. For carbon dioxide, it's CO2, and the O2 comes from the prefix di in front of the oxide. Dinitrogen pentoxide, you get N2O5. The 5 comes from the prefix pent, and the 2 on the nitrogen comes from the di in front of it. Alright, for number 1, it's nitric acid because NO3 is a polyatomic ion, thus you don't say the hydro in front of it. And since it's nitrate, you replace the 8 with ic. For number 2, it's also a polyatomic ion, and you use the same rules as number 1. For number 3, since it's not a polyatomic ion, you have the hydro in front of the iodic part of the thing. And then for number 4, it is also a polyatomic ion, so you don't have hydro in front of it. Perchloric acid is HClO4 because perchlorate is ClO4, and you just add the H in front of it to make it an acid. And phosphoric acid is H3PO4 because phosphate is PO4, and you put a subscript after the H because phosphate has a -3 charge. And hydrosulfuric acid is H2S because you add the 2 from the charge on sulfur. Carbonic acid is H2CO3 because carbonate is a polyatomic ion and has a -2 charge. To convert from Celsius to Kelvin, you add 273 to it. So 25 plus 273 is 298. And the same thing applies to number 2, 123 degrees Celsius plus 273 equals 396. And for number 3 and 4, the same thing applies from going from Kelvin to Celsius. You subtract 273 from the Kelvin. So when you subtract that from 453, you get 180. And for number 4, when you subtract 273 from 235, you get -38 degrees Celsius for your answer.
This majestic presentation is brought to you by Sabu Jobo, Kyle Garrett, and Dylan Ramsdale.